A polygon is a 3 or more sided convex figure. A regular polygon is a polygon that is both equiangular and equilateral. All the sides are the same, all the angles are the same. The interior angles of a polygon are all of the angles inside of the polygon. And the exterior angles of a polygon are all of the angles outside of the polygon. The polygon interior angles theorem tells us that the sum of all interior angles is equal to the number of sides, n, minus 2 times 180. And the reason for this is because if I triangulate a shape, which means I split it up into triangles from one vertex, I get 1, 2, 3 triangles. Now this shape has 1, 2, 3, 4, 5 sides. So 5 minus 2 is 3 triangles within this shape. And every triangle has 180 degrees in it. So if I take the number of triangles, each triangle has 180 degrees in it, I will get the total number of degrees for a 5-sided shape. The polygon exterior angles theorem tells me that no matter how many sides are in this thing, all of these exterior angles here will add up to 360 degrees, no matter what. A type of problem we saw in 7.1 was find the sum of the interior angles of a 23-gon. Well, we know that the sum of interior angles is always n minus 2 times 180. So, where n is the number of sides, so let me take 23 minus 2 times 180 is 21 times 180, which is 3,780 degrees.
Hello, my name is Pat Parallelogram. I am a special type of quadrilateral, which means I have 4 special sides right here. Me and my brothers and sisters have some very special properties of parallelograms, which I want to tell you about right now. This is my wife Petunia parallelogram. A special thing I love about Petunia is that her opposite sides are congruent. It's one of the things that makes her so beautiful. I love you, sweetheart. This is my brother Peter parallelogram. Peter, along with all of us other parallelograms, have opposite angles congruent. I love you, Peter. Come in here for a fist bump. Woo. This here is my sister parallelogram. Patricia! It's been so long since I've seen you, girl. How you been? Oh, Pat, I have been so good. Have you told everybody about how my consecutive angles are supplementary? Patricia, I have no idea what that means, but I sure hope you'll tell us. Oh, silly. It means that if you take one of my blue angles and one of my pink angles and you add them together, you get 180 degrees. 180 degrees. 180 degrees. This here is my cousin Patrick parallelogram. Patrick, what are those weird tattoos going across yourself? They're not tattoos, Pat. They're my diagonals. Remember, those are segments that connect opposite vertices. Well, Patrick, why do you have those weird diagonals on yourself? Because they bisect each other. Pat, don't you remember that bisect means to cut something in half? So this pink segment is the same as this pink segment. It's a magical, magical thing. An example of ways you can use properties of parallelograms can be seen to my right. If I wanted to find the value of x, well, I know that x and 145 have to add up to be 180 degrees because consecutive angles in a parallelogram are supplementary, which means if I subtract 145, x will need to be 35 degrees. Now, if x is 35 degrees, oh my goodness, we know that opposite angles are congruent. So that must mean that z is equal to 35 degrees. And wait a minute, with that logic of opposite angles are congruent, that means that y should be 145 degrees. Oh my goodness, would you look at that? Almost all of the converses of the theorems from section 7.2 are true as well. We'll discuss each of those in the following slides. The first theorem we saw in 7.2 was the opposite sides theorem. The converse of that theorem is true as well. It states, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. The next theorem we saw was the opposite angles theorem. It states that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral must be a parallelogram. This theorem actually wasn't mentioned in the last section at all. That's because this theorem is unique to proving quadrilaterals are parallelograms. The opposite sides parallel and congruent theorem states that if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. The last theorem of our section 7.3 is the parallelogram diagonals converse. It states that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. An example of a problem that would be seen in this section is finding the values of x and y that would make this quadrilateral a parallelogram. Well, the parallelogram opposite sides converse states that if opposite sides are congruent, this quadrilateral is a parallelogram. So I'll set the expressions for both opposite sides equal to each other. This gives me x plus 9 equals 2x minus 1, and y equals x plus 7. Solving the first equation yields x equals 10. Plugging that into the second equation yields y equals 17. Thus, we can conclude that this quadrilateral is a parallelogram only when x is 10 and y is 17.
This is the story of little Timmy the Square. Timmy the Square has a Papa rectangle and a Mama rhombus. You can see he got his dad's angles and his mom's sides. Papa rectangle is a parallelogram with 4 congruent angles, and Mama rhombus is a parallelogram with 4 congruent sides. Little Timmy the Square is a parallelogram with both 4 congruent sides and 4 congruent angles, so he is both a rectangle and a rhombus at the same time. So Mama rhombus and her friends have some special properties about them. Their diagonals always intersect at 90-degree angles. Further, their diagonals always bisect each angle of the rhombus. Papa Rectangle and his friends also have special properties about them. All of their diagonals are always congruent. Both diagonals are congruent. And little Timmy the Square, because he is both a rhombus and a rectangle, any property that is true for rhombuses and rectangles is also true for little Timmy the Square here. So here's an example of a problem that we could find in section 7.4. If Jm is 3x plus 4 and Lk is 2x plus 6, find x. So because Jm and Lk are both the diagonals, and we can tell that we have a rectangle here since all 4 angles are 90 degrees, we know that the diagonals of a rectangle are always congruent. So 3x plus 4 needs to equal 2x plus 6. And then we can work our algebra magic to get x equals 2.
Michelle, what are you doing? What's that, Michelle?
A trapezoid?
Why does that have markings the one on the board doesn't?
Well, this is an isosceles trapezoid.
What's the difference?
Well, a trapezoid is a quadrilateral with one pair of parallel sides. An isosceles trapezoid still has that pair of parallel sides, but also the legs are congruent.
Very interesting.
I'm glad you think so. Would you like to know more?
For sure.
Well, this is called the Midsegment Theorem. In an isosceles trapezoid, the midsegment is a segment that connects both midpoints of either leg. This midsegment is parallel to both bases, and it's the length of the average of the two bases.
Fascinating.
Yes, indeed.
That still doesn't explain why you were dancing.
Oh, yes. About that. The only way to properly explain that is to show you. It's part of my new trapezoid aerobic exercise routine for my New Year's resolution. So we start with the base angles theorem. If we have an isosceles trapezoid, then the base angles are congruent. So these two and these two are congruent. Yeah. What does the converse say? If these angles are congruent and these angles are congruent, then we have an isosceles trapezoid. Ooh, one more thing. If I have an isosceles trapezoid, the diagonals are congruent. Yeah.
Michelle, what are you doing?
I'm not done with my workout regimen. I'm trying to fly this kite.
That's not a kite.
Yeah, it is. It has 4 sides. It is a quadrilateral with 2 pairs of consecutive congruent sides. Boom. Kite.
What's so special about this kite?
Oh, I'm glad you asked. So this kite, the diagonals of it intersect at 90-degree angles, and the opposite angles, only one pair of opposite angles, specifically the pair between the sets of consecutive sides, are also congruent.
Michelle, what's wrong?
I'm too tired after all my workout regimen. I'm trying to find the length of this midsegment. I'm so tired.
Didn't you tell me it's just the average of the lengths of the bases?
Oh, I did. Is it that easy? 32 plus 38 divided by 2 is 70 divided by 2, which is 35. Wow!
My favorite part of Chapter 7 was all the cool lessons I got to make. It was really cool to see all the students think so critically, and I'm really looking forward to all the videos.